Hello everyone, my name is Nitipath and this is my second quarter AP Physics project where I will be solving a problem relating to waves and intensity. Alright, so a tsunami wave is about to hit the shoreline of a remote island in the Pacific Ocean and scientists want to know how much damage it will cause to the wildlife. The wave travels at a speed of 800 kilometers an hour. Calculated by finding the square root of the product of the depth of water and acceleration due to gravity. The tsunami originated from an 8.0 Richter underwater earthquake, whose epicenter is located 1,600 kilometers away from the island and is headed straight for a beach 5 kilometers in length. The earthquake happened for only 30 seconds, but generated approximately 60 million megawatt hours of power. Questions. What is the intensity of the wave on impact? And how much energy hits each kilometer of the beach in the first second of impact? Alright, so first things first, for question 1, we want to draw a diagram and figure out what equation we will be using. We know that the first part of the question is specifically asking for the intensity of the wave on impact, which means we will be using the formula for intensity. Intensity equals to power over area. So after this, we can draw a diagram as to picture the scenario. The island is 1,600 kilometers from the epicenter, and we can draw that out. Alright, so from the equation, we can also know that to find intensity, we're going to need to find power and area first. So let's look at power. We are given a measure of power generated by the earthquake, but we're going to have to convert this from megawatt hours to just regular watts. Megawatt hours are literally just how many megawatts per hour. So by dividing the given by unit of time, which in this case will be the time taken to generate the power, and then multiplying the megawatt value by 10 to the power of 6, we can get the unit in regular watts. But do keep in mind to make sure you convert seconds into hours before dividing. So now that we know that the earthquake generated a total of 7.2 times 10 to the power of 15 watts, we can use this to calculate. This is a lot of power. Right. Next, area. We know that as wave energy spreads out, it spreads in a way that maximizes volume covered while minimizing the radius, which leaves us with a sphere. However, in this case, energy is not dissipated in the shape of a sphere. Instead, energy is dissipated in a shape that resembles a sector of a sphere, though the bottom base can be ignored as the energy from the waves won't be dissipated in that direction, leaving us with finding the surface area of the spherical zone, which is the area excluding both bases. We'll call this A1, and the area covered on the surface of the ocean, we'll be calling this A2. Spherical zone. We know that the equation for the surface area of a regular sphere is 4 pi r squared when the height of the circle segment is equal to the diameter, which is 2r, meaning that we can derive an equation for the spherical zone by substituting 2r with h, giving us the equation a equals to 2 pi r h. And now we have two new variables to solve for: height, which is the depth of the water, and radius, which is the distance from the epicenter to the island at sea level. Height. Now, even though height isn't given, we can find height using the velocity of the wave, which is given. As mentioned in the scenario, the velocity of a tsunami wave is found by finding the square root of the product of the depth of water and acceleration due to gravity. So first, we convert kilometers per hour to meters per second, then substitute acceleration due to gravity with 9.8 meters per second squared, giving us the approximate depth of 5,000 meters or 5 kilometers. Now, if we want to be a little extra, we can use this to find the true radius of the sphere using the Pythagorean theorem, but it's negligible. So now we can substitute our values and find the value of A1, which equals to approximately 50,000 square kilometers. A2 is a bit easier to find, simply using the formula for the area of a circle, with radius equaling to 1,600 kilometers, giving us the value of 8.04 times 10 to the power of 6 kilometers squared. Now, We can add both A1 and A2 together to find the total area the energy from the earthquake can dissipate to, and this will give us a grand total of 8.09 times 10 to the power of 6 kilometers squared. Finally, to find the intensity, substitute both values into the initial equation to find the intensity of the tsunami crashing onto the island 1,600 kilometers away. This gives us a total intensity of 8.9 times 10 to the power of 9 watts per square kilometer. And with this, we can find the total amount of energy hitting the beach. To find the total amount of energy hitting each kilometer of the beach in the first second, we multiply the intensity by the amount of beach affected in kilometers, so 5 kilometers, then convert watts into joules by multiplying it with the amount of time it's taking place. So in this case, 1 second, giving us a total of 4.45 times 10 to the power of 10 joules per kilometer of beach. Thank you very much.